Here in this video, this will be an introduction into Bose-Einstein Condensate, a very particularly interesting state of matter possible in low energy situations. Looking at the various states of matter, commonly known ones, solids, liquids, gases, essentially correlating to the kinetic energy of a substance. As the energy increases, that's how most solids eventually transition to the liquid state and then the gas state. And if energy is applied even more, plasma, where ions form and separate. But on the low energy scale is where Bose-Einstein condensate was theoretically thought to occur. And what Bose-Einstein condensate, or BEC, really is a state of matter where atoms or even subatomic particles are brought to temperatures near absolute zero, as close to the lowest possible temperature available, which would be 0 Kelvin, resulting in a material that as a whole can be represented with a single wave function, which is unique in its ability to represent with a parameter the wave function that is used for individual electrons and small partitions of matter. But in this case, for BEC, can be used to represent a more macroscopic material. Now, as the chart earlier implied, BEC is possible with low energy, as in low kinetic energy, temperature being the average kinetic energy. BEC is possible at low temperatures brought near to 0 Kelvin, and a successful situation of gaseous Bose-Einstein condensate was discovered in 1995, which was brought about through the cooling of a Rubidium-87 cloud of atoms to 20 nanokelvin, or 20 times 10 to the negative 9th kelvins. The method by which this was done was trapping rubidium vapor within a magnetic trap or a magnetic potential, and then through successively changing the magnetic potential, eventually lowering the temperature through evaporative cooling. This is simply evaporative cooling on this scale is simply using a magnetic potential to trap atoms of rubidium that have all their various kinetic energies, therefore having an overall average temperature to that average kinetic energy, and then certain atoms of rubidium with higher kinetic energy will have the energy to fall out of that trap, and then through collisions, the remaining rubidium atoms will eventually reach some thermal re-equilibrated equilibrium where they pull down to the bottom of the well, and then that magnetic well or the magnetic walls will be lowered again so that higher kinetic energy atoms can once again fall out, and this process is repeated over and over again until there is just a low kinetic energy sample of rubidium atoms trapped in a Bose-Einstein condensate state of matter. This was first noticed around 170 nanokelvin, but the lowest that was achieved in this particular experiment in 1995 was 20 nanokelvin, at which point Bose-Einstein condensate as a vapor was observed.